Welcome to everyone. My IP version 6 session of series. I'm Kundan, technical team of Networkers Home. Today I will discuss configuration of IP version 6 on router. Basic IP configuration, all types of dynamic routing protocol, how we are going to configure under IP version 6 on router. So here we have the example that we can manually configure IPv6 addresses on all interface. Other options we have configure route advertisement LAN 1 and LAN 2 only. Install default route to router 2. Route advertisement means if we have multiple server, which server is going to provide automatic IP to all client system, that comes under route advertisement. And here FE80 part, actually it is the link local address. So these are the examples, the LAN 1 2001 colon DB8 colon C 18 colon 1 double colon 64. And after that, after double colon, we are not provide anything. It means we are assigning link local address for that which consists MAC address. So these are the options we have under IP version 6. So link local IPv6 addresses can be used instead of site local or global address. Then this following things must be configured. That neighbor IPv6 address update source, identify interface using update source command. Other option, apply a route map to get the global address in the next hop address. Now here you can see first IP version 6 remains disabled by default. So first command we need to execute, that is IPv6 unicast routing. Then in the interface, what the addresses we assign, syntax is IPv6 address. Then 2001, 2001, 2002, 2003, first hectare. Right now we are following this thing. Then here we have used DB8 colon C181 colon 1. So 2001 colon DB8 colon C18 colon 1, this part of the network. And double colon A belongs to host. Double colon means all the addresses of host portions are set to 0, and then A is the belongs to particular user, router's interface address, and CID 64 because first 4 oct hexet must be common between two directly connected router's interface. Another option we have IPv6 neighbor discovery prefix. This configuration we are using when we are using command IPv6 address autoconfig enable on user side. In that case, we have the option. We have the two router right now on LAN router 2 and router 1. So which is going to provide automatic IP to the users. Then we are providing the preferences and default route, that is double colon 0 Ethernet. These are the IPv6 route. Then double colon CIDR 0, whatever the information. And then which interface, Ethernet 0 or what the link local address we want. These are the options we have under IP version 6. So IPv6 ICMP echo request to default router as mentioned in my previous series. IP version 6 doesn't support ARP resolution. In place of ARP, it uses IPv6 neighbor discovery features, which has router advertisement, router solicitation, neighbor advertisement, and neighbor solicitation. That's why not a single echo is dropped when we try to execute. And the neighbor discovery cache in our router, we have the two IPv6 neighbor. It will provide you the IPv6 addresses. First is the link local address along with the MAC address. And then we have the addresses, age, link layer address, state, and interface, all information we are receiving. And debug IPv6 packet, we are applying this command debug IPv6 packet to come to know what are the states we have under IP version 6 neighbor discovery mechanism and what is the first work performed by router after assigning IPv6 addresses, that is duplicate address detection. Debug IP version 6 ICMP, all the ICMP echo parameter we will come to know. Neighbor discovery, what are the steps it is going to follow, and debug IPv6 routing, which routing we have enabled and whatever the information we have it will provide us each and every information. So here we have debug IP version 6 ICMP example. So IPv6 I say echo request and reply to the router, and then it receives route advertisement message received ICMP-v6 packet from this information, and it shows the type. Either it is type 129, that is echo request, and reply part type 134. Now we will discuss how to enable dynamic routing protocol. Actually, IP version 6 follows the basic fundamental what we have in ISS protocol. We doesn't require network command under IP version 6. Directly under interface mode, this is going to enable. So IP version 4 RIP is called RIP next generation. Same as IP version 4, it is distance vector, radius of 15 hops, split horizon, Poisson reverse, and so on. It uses UDP port number 521. In IP version 4, it uses UDP port number 522. And based on RIP version 2 means, we do not have any classful and classless mechanism in IP version 6, but it shares all topologies information with the neighbor. That's why it is based upon the RIP version 2. Update features of IP version 6, IP version prefix, next hop, link local address, next hop interface address. This information we have used the all RIP router multicast group in IP version 4 RIP join, RIP version 2 join 224.0.09. Here FF02 reserved for multicast double colon 9. All destination uses IP version 6 for transport and name RIP next generation. And the command syntax is on the router, if you want for the distribution purpose, we can use IP version 6 router if what the tag means what the instance name I want to use. And then distribute static BGP RIP, anything we can use. And then interface mode IP version 6 RIP, what the name, instead of what the tag part, what the instance name you want to use, and then enable keyword is required. And if I want a router under IP version 6 in the RIP next generation becomes default route for RIP next generation neighbor, then IP version 6 RIP interface mode, name, and default information originate. And we will get double colon 0 mentioning which interface this is becomes default router for which neighbor. And the commands to verify that part we have. So IPv6 RIP displays the status of the various RIP processors. So IPv6 RIP database, it provides all the design topology information. So IPv6 route RIP will provide routing information, the best path information. And if we want to check what are the multicast addresses it has joined, what all parameters it is going to follow, then all the packet received certain information will receive using command debug IP version 6 RIP. And here is the example. First, we need to provide IP addresses, interface, then IP version 6 RIP. We have used RTO, enable, and IP version RTO default information originate. So when you will use debug IP version 6 RIP, sending multicast update on Ethernet 0 for RTO, that is the instance tag name, source, then destination, source port, destination port, length, command version, these are for the RIP database RIP header information, and what are the prefix default it is going to generate. Same information here we have how to configure RIP on the router's interface. The instance tag name is for locally significant. If you want, you can change this parameter. Post assign addresses on the interface. It is UI64 format, which is going to use link local address, and then enable RIP. We doesn't require any network command in any dynamic routing protocol under RIP. For OSPF, similar to IP version 4, same mechanism, but rewrite of the protocol. That's why OSPF never comes under address family. Update features for IP version 6, all IPv6 addressing semantics removed. IPv6 addresses carrying the payload, not header. Link local address used as the source. IPv6 as transport. And OSPF v3 enable per link, not network. Remember, per link. So individually need to enable on the connected interfaces. OSPF v3 require router to running SEP. Cisco Express forwarding is required if we want to enable it properly. And router ID, area ID, and link state ID remains 32-bit, not derived from our IPv6 addresses. Router LSA and network LSA do not contain addresses, only 32-bit identifiers. LSAs now have a flooding scope, define a radius, link local area autonomous system. Handling and forwarding of unknown LSAs supported. Uses IPv6 link local multicast address, that is FF02:5. This is for in IP version 4 it is called DR other. Here it is OSPF router, and 6 for the DR. And the enable part is very simple. After assigning IPv6 addresses, IPv6 OSPF, what the process ID we want to choose, and the area number we want to use. Instead of the 000, automatically you can see 0. And if you want to provide router ID, then we have the syntax on the global configuration mode. After IPv6 router OSPF 99, what the area process ID you want to use, then we will option to provide router ID. So remember one point again, IP version 4 addresses could not assign as router ID. That's why we required IPv4 address. And what the area range, and this is the syntax we are applying summarization procedure under IP version 6 in OSPF. And so IPv6 OSPF process, it provides process ID, area ID. So IPv6 OSPF, same thing, display OSPF related information, general information, and clear IPv6 OSPF force SPF. If we want to restart the process, here is the option, clear IPv6 OSPF 4 shortest path features. EIGRP, that is the part, all features like same, IP version 4, IPX, and all it supports like in IP version 4, as supports all routed protocol using protocol dependent module features, easy to converge, and the fast converge. And remember, EIGRP remains disabled under IP version 6. So first we need to configure on the global mode IPv6 router EIGRP, then we need to use autonomous system number. If we want to provide, then we will provide IPv4 addresses as router ID, and then we require to use no set command. On interface mode, on the global mode, first we have initiated EIGRP process autonomous system 121. On interface mode command, we have IPv6 EIGRP 121. But before applying this part, remember, one IPv4 address remains for the router ID must be enabled, and then EIGRP need to use command no set. RIP required enable keyword, OSPF doesn't require these processes, and EIGRP remains set by default. And ISIS actually intermediate system to intermediate system, already previously it was IP version 6 hexadecimal based. It is easily accommodated under IP version 6. It is the part of IGP, link state routing protocol, supports multiple network protocol at the same time, use the same SPF for all network protocol. It uses two type length value added to introduce IPv6 routing, IPv6 reachability type length value, and IPv6 interface address. New protocol identifier IPv6 NLPID, network layer protocol, that is PDU identifier, advertise IPv6 enable routers. As we know, ISIS protocol doesn't join multicast good, it uses link local layer 2 header information to form the routing adjacencies. So IPv6, IPv4, IPv6 router, IPv4 only router. A single SPF shortest path runs per level for OSI IPv4 IP version 6. All routers in an area must run the same set of protocol, IPv4 only, IPv6 only, IPv4, IPv6. A single SPF runs per level OSI, IPv4 same route. Layer 2 router must be configured differently, but no routing hole must exist. So ISIS protocol requires label, and level 2 router communicate only with the level 2. Otherwise, we require level 1 2 router, level 1 database as the separate part. And multi-topology supports means at a time it is going to support IP version 4 as well as IP version 6. And separate SPF for it has in separate shortest path algorithm for IP version 4 as per IP version 6. It removes some limitations to network design when running ISS for both IP version 4 IP version 6, and it is available today. Only we required address family IPv6 multi-topology. That command we required. We need to follow this step: configure generic ISS interface attribute, configure ISS v6 on interface, configure ISS router mode attribute, configure ISS IPv6 specific attributes. Because first we decide what the ANSAP address and what the ISS type we want to initiate. So on the global mode IPv6 router ISS, if we want, we can use name, otherwise it's fine. And then address family IPv6, maximum path, default information originate, multiple options we have. Administrative distance we want to set it, practically it has 115. Maximum path we can decide, that is 1 to 4, and IPv6 default route. If we want to decide level information under interface configuration mode, the command is ISS circuit type. Otherwise, ISS type under router configuration mode. Here you can see router ISS, address family IPv6, distributed static, default information originate, and then this is entities network entity title, address formative information, that is 49 or 47. Then we have the area ID 002. After that, we have the 1921.608.03.001. This is called the system ID. And then 00 is the net selector. It always remains 0. So same information you will find. This way we are going to provide. Another option we have router ISS, address family IPv6. Only IPv6 remains enabled. That's why we have not executed command topology, multi-topology part. On the same router configuration mode, we have the option to provide the ISS type, otherwise circuit type we are using. And only command is IPv6 router ISS. Same features adopted by all dynamic routing protocol under IP version 6. IP version 6 ISS command, IPv6 router ISS, IPv4 router ISS. That remains common in the both IP version 4 as well as IP version 6. And so IPv6 route ISS I2, that is level 2 information, level 2 database we have used via link local address. This information we are having. And IPv6 over GRE, remember, by default in GRE, IPv4 remains enabled. And if we want to execute IPv6 on in GRE, then address family IPv6. That command is required. IPv6 router ISS, that is IPv6 address, tunnel source, tunnel destination, IPv6 router ISS. This thing we required, an address family IPv6. That's all. Then it is going to work. So IPv6 protocol, it will provide ISS is configured, database. It consists two database and topology, two part we have. Adjacency packets we can check, it has two neighbor command. So multiple options we have under IP version 6. And for the border gateway protocol, multi-protocol extension for BGP4 in IP version 6 enables other protocol based IPv4, new identifier for address family. We have two options. On the global mode, we can establish neighborship, then activate command is required under interface address family. Directly we can execute, activate will there, neighbor already can be assigned under address family. So IPv6 specific extensions we have scoped addresses. Next hop contain a global IPv6 address and potentially a link local address only when there is a link local reachability with the peer. If peers having link local reachability, then it is required. Next hop an NLRI, that is router ID expresses IPv6 addresses and prefixes in the multi-protocol attribute. So look here, you can see that router BGP is 65001, no BGP, default IPv4 unicast, we want to use IP version 6. Then router ID, neighbor, on the global mode, we have given the neighbor. Then under interface mode, first command is what the neighbor, who the router my neighbor is, activate command, and then what the prefixes information you want to use. And then exit address family. In and out, if you want to apply any type of policies, then what the in and out we want to use. But activation is required. And here also you can see that what we have used here, BGP router ID, neighbor, activate, address family IPv6. But activation always under address family IPv6. Route reflector client, next hop self, network command, all information we have under address family. And then if you want to apply the route map, there's a set IPv6 next hop, which is my next hop. This all options we can use. And then what the route map name we have given, in and out depend upon our requirement. Here what we require to configure BGP to extract legal IPv6 prefix only, data prefix list, prefer route from autonomous system 645000 to local preference. Local preference we want to apply. These are the options you have. That we have formed the BGP neighborship, we have done the activation command, and prefixes legal in which information you want to receive. And then we have IPv6 prefix list legal, we have given the name, sequence 10, permit sequence 20, less than or equal to 32. All parameters remain the same, but we have in IP version 4 only syntax required IPv6 prefix. And the route map information, what the intent set local preference 120, this parameter remain the same, what we have in IP version 4. Only execution part is different. And remember, activation is required. And route map in every parameter remains the same for the local preference for weight, MED, there doesn't have any difference. And so BGP IPv6 summary. Same information we are receiving in IP version 4, that is show IP BGP summary. Here command show BGP IPv6 summary. The memory utilized by BGP on the particular router, what the neighbor version is, and total prefixes we received. Every information we are having. The syntax is same only. So BGP IPv6 summary is required. So next time we will discuss another features of IP version 6. Thank you.